Hi, I welcome all of you to my YouTube channel Organic Chemistry with Dr. Naveed Iqbal. So today we will be studying magnetic quantum numbers. So let us review that what we studied. We studied the principal quantum number, the azimuthal quantum number, and now we are studying the magnetic quantum number. Actually, as I mentioned earlier, that these quantum numbers just provide us some numbers, 1, 2, 3, 0, etc., etc., and these numbers have some meanings associated with it. So now let me review briefly that what we studied. We studied the principal quantum number, that what this principal quantum number was telling us. It just told us or gave us the information about the shells and the energy of electron in a shell. That what will be the energy of an electron in a shell, as the shell decreases, the number of as the principal quantum number increases, the energy of that electron also increases. But as you know that the shell is just an electron cloud. Another analogy I want to give you: if you are going in an aeroplane and you view the earth or a city, you will be seeing very small all the houses and buildings and roads. They are just vague. You can't differentiate between them. You just see a vague picture, not clear things. So principal quantum number just tell us about the shell. Now the azimuthal quantum number gave us some other numbers, that what shapes are present inside that principal quantum number or that shell. What shapes of what shapes the principal shell is composed of. So as we studied that when K shell have just one spherical shape, L principal quantum number, when it is 2, it gives us the L shape, energy level second. The energy level second has two shapes. One was a spherical, one 2s orbital, and another a dumbbell also. A dumbbell shape thing was also present in that. And the third shell provided us an information about an additional double dumbbell shape also present in it. So the third shell has an S, a dumbbell, and a double dumbbell. And the fourth shell has S, the P, the D, and the F orbital present. These are the shapes, and these orbitals or these shell actually look like this. So this information was given to us by the azimuthal quantum number. What the magnetic quantum number tells us? Now the magnetic quantum number is very important. It gives us two informations, that how many shapes are there in one shell, and what are the ways or how they are oriented in space. From orientation in space, I mean that when you look at them from in space, that how they look like. Suppose my hand look like this in space, it can be like this, or it could be like this. So that's what the magnetic quantum number tells us. Now, relation between L and M. So this is very important. This relation will tell us that what will it tell us? It will just tell us that how many compartments are there in how many shapes are there. I mean to say that if there is the azimuthal quantum number just told us that there is a dumbbell shape. Now the magnetic quantum number will tell us that how many are they, and how they are oriented in space. So let's go. This is the formula. They say they have just devised this formula for it. M is equal to plus minus L. Suppose now we are relating the azimuthal quantum number with the magnetic quantum numbers. So if you have L is equal to 0, now you are talking about the S orbital. We know that it is a spherical shape, and how many orientations are possible for it. So if L is equal to 0, I have written it here, plus minus 0. So L is equal to 0. It gives us a single number. Forget about it give us 0 or something, plus minus or anything, but it's a single number, and it says that it has just one orientation. Just like if you have a ball, it's still a ball. if you move it and it's again a ball, in every direction when you see it, you will see it in a spherical shape. You will be just seeing that it's something round. From everywhere, anywhere when you want to see that ball, it will be round, so it has just one orientation in space. L is equal to 1, so m is equal to plus minus 1. Now something else. It's talking about the p orbital. L is equal to 1 was the p shape or dumbbell shape. How many dumbbell shapes are? So you have it gives us this information plus minus 1. So we have to start from minus 1 and move towards plus 1 through 0. Minus 1, 0 and plus 1. Now 3 number arises. So these numbers, now what it tells us, this magnetic quantum tells us that this dumbbell shape thing, there are 3 compartments and they are arranged in 3 ways. So what they are, p orbital, that was p orbital, px, py and pc. These are 3 compartments and they are arranged in px, py and pz direction. Now these let me share with you that how they are arranged. So this is a coordinate system, x, z, y. So px will look like this, px, py and pz will look like this. So it's oriented in 3 directions on the x-axis. So these things will be clear to you in the next lecture when we will be discussing the shapes of the orbitals and their orientation through models. I have just made some homemade models. And you will enjoy that. That's too much ugly, but that will be quite helpful in understanding those things. For some students, majority of the students understand these things, and some students would need an additional help of the model to understand that. So I have another video for that, and just watch it. In the next video you will be able to understand it more. So now let's go. If L is equal to 2, L is equal to 2 mean that we are talking about the d orbital. L is equal to 2, so m is equal to plus minus 2. Now we are talking about the d orbital. So minus 2, minus 1, 0, plus 1 and plus 2. Now as you see, there are 4 things. It gives us 4 numbers. 5 numbers. 1, 2, 3, 4, 5 numbers. So there are 5 compartments and there are 5 ways that these compartments are arranged, and roughly we know from our preliminary knowledge that d orbital is a double dumbbell. It's double dumbbell. And how they are arranged in the next video would be when you see, you will understand through models. Right now I would just write them, that they are arranged in d is the orbital, xy, d yz, d zx, dx squared minus y squared, and dz squared. These all have d in common, but this xy have some meaning, this yz has some meaning, this zx has, and this thing has also some meaning, and then this z squared has also some meanings associated with it. So in the next video I will explain these all, that how they are oriented, these d orbitals or p orbitals are oriented in space. So thank you very much.